Now, okay. I get to say welcome back, even though it's my first time here. And even though we as Baltic Mobility are also still very new to this community, we're actually in the process of becoming a member. Still, I get to say welcome back because my colleague Jan, who's sitting there in the back, he talked last time at the community days about the cloud, the automotive cloud. So we're going a bit away from the microcontrollers, we're going into the cloud environment. Jan mostly talked about technical issues, about things like scalability, about resilience and similar things. Today, from our side, we'll talk a bit more about business. So what are the problems that an automotive cloud solves? What are the problems and the challenges and the essentials for an automotive cloud? What does it have to bring with it to be a good automotive cloud? So I just want to take a step back to start. So, because I said I want to talk about business, just to give a bit of context so we're all on the same page of why are we doing this. So why do you need connectivity for vehicles? Much of the stuff we talk about in SDV could be just a vehicle, a non-connected vehicle. But you will very soon see that in our view, connectivity is getting just so much more important, and it's going to be an integral part of the SDV. So it starts on the top right with updates. As soon as the vehicle is in the field, it's not done. So it's going to receive updates throughout its whole lifetime, and that's 15 years usually. Why do you want to upgrade your vehicle? Of course, to upgrade the value of your vehicle once it's in customer hands, but also to save costs. If you have recalls and you can do them through an online update, that's much cheaper than getting thousands and tens of thousands of vehicles back into the workshops. Cost of development as well. Anything you can develop in software is usually cheaper than if you have to develop it in hardware. The same is true for software that you develop for the cloud. It's usually cheaper than developing it for tens and hundreds of thousands of embedded devices. So these are like the hygiene factors. So that's why you have to do it. Now, the factors why you want to do it, well, it's easy. You want to enable new business models. Everybody talks about this. Nobody knows how fast they will come, but likely they will come in some way. Enabled, shared and fleet modes of ownership in vehicles. They are inherently connected modes of vehicles. Autonomous driving. Everybody talks about autonomous driving being a really big challenge, but few people talk about the fact that autonomous driving will never work if it's not in a connected vehicle. So many factors around autonomous driving will require connectivity. And finally, you want to have your vehicle as a center of an ecosystem. This is the famous iPhone analogy. It will come to the vehicle in some form, app stores, third parties, because we have great ideas of customer value for our vehicles, but well, we're an open source community. The more people contribute with ideas, the better. So this is kind of the context where we want to solve problems with SDV and also with an automotive cloud. So today we're going to pick out a few of those, and we're just going to throw the problems in the room, and we're not going to come with all the solutions because we only have 30 minutes. Daniel will start with the process of what needs to happen once a vehicle is produced, once the vehicle is born, until it gets into the hands of the customer, until it's really connected. So that in itself is an interesting process already. Secondly, I'll talk a bit about a few of the things that happen once the vehicle is in the customer's hands. You don't have the vehicle anymore, but it's driving around in the real world. What you have to do to manage your fleet there. I'll talk about communication patterns. I'll talk about what needs to happen in an automotive cloud with telemetry data, because there's a lot to do about that. I'll talk about the relation between a user and his or her vehicle and privacy. Quite a core topic of an automotive cloud. A lot of thought needs to go into that. And finally, to round up the picture of enabling a business platform on a vehicle and around a vehicle. And finally, Daniel will tell a little bit of why all of this is extra complicated. So with that, Daniel, I think you can. Oh no, I have, yes. I have two very quick remarks. Maybe you have already noticed when I talk about software, when we talk about software here, we're talking about software running on HPCs or in the cloud. We'll not be talking about embedded software, and we'll not be talking about microcontrollers, anything close to hardware. Don't ask us. The second assumption is when we talk about vehicles, we don't talk about vehicle projects, vehicles that have their SOP in 2 years, in a development mode. We don't talk about vehicles right here in the production, but usually we'll talk about vehicles that are already sold at the customer. You have less control about them. You cannot access them physically, and the hardware is fixed. So this is kind of the base assumptions to be able to understand what we do, and that's true for almost everything except the few sentences that Daniel will start with.
So let's have a view about what SDV was actually worth. So I think that slide is most surprise for anyone. We need key security. So on the one hand,
so you want to have certificates, so you need a public key infrastructure. You need to decide whether do you run yourself or you need someone who helps you do it. You want to have one certificate in a vehicle, many more in the cloud. Of course, you need cryptography for encryption, digital signatures, stuff like that. If you make it real good, you think a lot about algorithms you're using. They could be maybe old. So, finally, you need authentication and authorization. So OAuth is a quite good option. Teach you a cloud providing authorization server. Sometimes we call it in our project identity provider. And you have to teach your cloud services becoming our authorization server, being part of OAuth infrastructure and doing all the stuff you see on the slide, implementing your OAuth. Secondly, we are something like, I don't like the sentence, but we are mobile phones on vehicles, right? So at least here. And so we need SIM cards or SIMs, embedded SIMs in the vehicle. So you as OEM, of course, need to talk to MNOs, mobile network operators. You have multiple of them around the world. So OEMs are typically around the world. So I have to talk to multiple MNOs. And you have to make sure, you will see it also on the next slide, that you register your vehicle in a round country. So you have to do it somewhere in the production process. And as far as we know, there is no standard provided by MNOs. So you could need some kind of abstraction of MNO communication in your automotive cloud. And last but not least, you want to be able to manage who pays for the traffic, right? So you need to know that there are things like access point name. You can also see on your mobile phone. So it's connectivity basing. Don't ask me after that. I'm not a connectivity guy, but I ask people. Okay. Now it's maybe a quite hard slide, but I think it's good overview for you to see how our process of establishing trust could work. As Storm marked out, we are on real in-vehicle cars, that living the factory. So it begins with I call it OCU. I know there are multiple names for those devices, but you're having an online ECU, and it's assembled into the vehicle. Of course, it's being done. Yes, as you can see, it's obvious thing. Interesting first step where the automotive cloud comes into game is when you provision activate the embedded SIM. And so here the cloud enters the game. And important stuff is, I think many of you know about this, that key creation is a very sensitive process, and you see, yeah, you have to resolve it your way, right? So, you know, it's an activity diagram, but it's a list of problems, okay? It's not a list of solutions. So in the first swim line, we got now trusted connectivity. So let's finalize that process. We want to register the vehicle in the automotive cloud, enabling digital twin and maybe any other features. It's a good practice to have synchronization between backend and the car, direct synchronization. We have seen it already different way, you know, the people filling manually databases and so stuff like that. And so yeah, finally we are online, trusted online, and we are capable of being authorized in our automotive cloud. My final slide on this topic before I give over to Torben. So it's important to understand, you know, now as we have the trusted connectivity, there are many players in the game. Okay, so you are, as developer, as architect, need to decide how is now the real end-to-end connection. Okay, do you want to go via proxy? Okay, do you have a do you want to be very, very quick and you want to talk directly to the cloud without proxy? Then you might maybe have to talk to IT security and stuff like that. And in the back end, there are third parties. We call those people. So you will 100% you will have players in the cloud. Because they are innovative, they provide cool features. You want to have them in your vehicle because you want your vehicle to be cool, innovative, but they cannot become part of your trusted environment. Okay, how do you do that? Okay, so there are two simple options. You could create a proxy in your automotive cloud, or you introduce a process that you do some kind of whitelisting in a vehicle. And for instance, yeah, I think some of you heard already about it. So here, now we are trusted, connected, and I give over to Torben.
Okay, thanks. Okay, now we have the vehicle in the cloud. Let's or the cloud in the vehicle. Let's extend them both into each other and look at how they communicate a little bit. To be honest, I'll be short on this slide because it's probably a bit insulting in the depth of it for many of the people here. It's just a reminder that when you communicate between vehicle and cloud, you talk about very different modes of communication. So we often come up with very simplistic examples in the beginning. That's very natural to get started on some open source project or just some end-to-end demo. And then it's usually some kind of RPC style communication. So you request a status from the vehicle and you get it back, something like this. A pattern that we see more often in our experience in cloud vehicle connectivity is asynchronous modes of communication. So just give a notification to the vehicle or receive or the vehicle gives a notification to the cloud. We see that. And actually, both of these can be kind of covered with a newish concept of a digital twin that I'm not going to explain because I learned Microsoft is going to talk about that later, about one project that covers the digital twin as well. But a lot of this can be covered by this kind of communication. But also think about the fact that there are other types of communication. Streaming is becoming more important. You have things like camera data streaming from the vehicle. You have things like voice data streaming from the vehicle, for example, to use it in the backend through some LLM. Telemetry data, in some use cases, you want to stream it from the vehicle into the backend and use it there. Well, and of course, in the other direction, you have music, any kind of media you want to consume in the vehicle. Also files, upload, download, very old style, but it's still there and it's still needed. One direction could be for logs from the vehicles, measurement data that you want to make available in the cloud. In the other direction, a typical example would be binaries for updating anything in the vehicle. And remember, that's really one core goal of connected vehicles. So my message here is, even though you're connected, even though you have your SIM card and you trust each other, Designing this communication in a smart way is not easy. So choose wisely what kind of what kind of pattern you want to use, and also think of orchestrating. For many business services, you don't want to worry about all that. You just want to have your communication. More often than not, you would also want to offer higher level APIs that maybe orchestrate all of those different modes of communication. Just an example, updating of anything in the vehicle. Well, maybe the cloud wants to give a notification to the vehicle that a new release for some embedded software is there, and the vehicle should check whether it needs that, and then that could be a notification, and then the vehicle, requests something from the backend, some status that could be in RPC style information, and then it downloads the binary. So you do have an orchestration of all of those, and the real value comes in looking at your business problems you want to solve here and orchestrate it well. And much of that intelligence will likely be distributed between vehicle and cloud. To close up the topic of communication, I have a few of the non-functional aspects of it that are really important. You can't design a nice cloud connectivity without those. Starts with security. Where do you want to have your TLS endpoints? Of course, talking about an unsafe internet, you'll be encrypting your communication. But how about in the vehicle? How about in the cloud? Where do you have your endpoints? How much do you want to encrypt? There's no black and white answer here, but that's definitely a design consideration. Well, good old permission management, authentication, authorization, that's always a topic. And I'll come to that a bit more in a bit. A topic that has given us quite some headaches, especially Jan in the past, is unintentional DDoSing yourself. So you have a lot of vehicles in the field that are built the same way, so they react to the same events the same way. And then now imagine you have an event like a mobile phone outage or mobile network outage actually. And then the mobile networks come back and all the vehicles do the same thing. So they essentially DDoS your cloud. So what do you do about this? There are a few things you can do. Is you can design the traffic better. Not everyone has to do everything at the same time. In the cloud, you can use circuit breakers. You can use dynamic scaling to a certain degree, but that has limits as well as soon as you hit the database. So this is a big problem. Then you have topics about when going over an unsafe network, and that's the internet, you have no guarantee, or it's difficult to have quality of service, to have guarantees of delivery. And if you're talking about quality of service, you also have to talk about idempotency of the semantics of your communication. You want to give a communication, a notification. You're not sure it arrived, so you give it again. It should have the same result still. A topic that can't be valued highly enough is prioritization of communication. You have in the communication between a vehicle cloud, you have important stuff and not so important stuff. You have timely stuff and not so timely stuff. So you don't ever want to have an e-call not going out because somebody is streaming a movie. So sounds trivial, but on a less trivial way, you need to have different communication channels at the same time. Potentially even going down to the physical, to the SIM level. Well, it's a design choice how deep you want to separate your traffic in order to be sure that the higher priority traffic goes through. And finally, what Daniel mentioned already, some of the traffic will be paid by the OEM, updates, basic stuff, basic connectivity, and some of the traffic will definitely be customer paid, likely streaming music, streaming movies and stuff. Now, I promised I just throw a few topics, so it's seemingly a bit unrelated. So we're now going to telemetry data. Now we have telemetry data coming out of the car. So what does an automotive cloud need to do this here? And I'm convinced that this is an essential part of any automotive cloud. Well, first of all, it needs to decide what data should be coming out of the car, what data is collected, and because a car produces so much data that you can't just have it all in the cloud. just not feasible anymore. And B, EU Data Act coming. And so what you need is a data ordering process. So you need a process where someone in the backend can say, okay, this is the data that I want to see, and I want to see it from the following vehicles. And that's quite a complex topic in itself. Once you receive data, you need to receive it, stream it, transform it, maybe stream it again. And you need to deliver it to the rightful recipient. So you need to have authorization there. You have to have identity and access management, push and pull mechanisms. And whenever you talk about data that is produced by cars, it's usually personal data of the person driving the car, because it says something about their position, about their driving behavior, whatever. So you're very much into the realm of EU data protection regulation. So that means you need to manage the consent or legal basis why you are getting data out of the car, and what are you doing with it. You need to be able to inform people what data you have, and you need to be able to delete it after you don't need it anymore. So this comes then to all the organizational aspects of product ownership, and all those need to be baked into an automotive cloud as well. You need to do quality control on your data. You need to do support your data. Actually, I didn't read the statement on the top. We're talking about data products here. So anything that you need to do for products, you need to do it for the data products here. You need to manage the access. You need to price them maybe. You need to have support, all of that. So making telemetry data into data products is a huge part and a central part of an automotive cloud. Next, we've talked about the relation between the cloud and the vehicles, so it's one-to-N, but really it's one-to-N to M because you have users connected to the vehicles, and that's also a very non-trivial relation. But if you look at the roles users can have in the vehicle, it starts very easy with the owner. Simple enough, but how do you get the owner role? You need to prove that you're the owner or that you're in possession of the vehicle. That's one topic. And there are, believe me, there are many ways of implementing this. So in the end, you always want to be able for someone to prove that they're owner or in possession of the vehicle, but there's so many variants of implementing this. And it gets even more interesting. You will want to know who is the driver of the vehicle, because you need to act in different ways when it comes to data protection, when it comes to activating servers, and just so many things. And knowing who's the driver of the vehicle, well, it's super complicated. You can have things like an explicit sign-in. Some OEMs do this, but the problem is who does that? Who goes into the car? They drive 1 kilometer to get some bread from the supermarket. They're not going to log in. So in the end, you don't know who's driving. There are a few other ways to do it. You can recognize the phone, but what happens if 2 people come into the car at the same time and they both have the phone with them? You can have physical keys, but how long are cars going to have physical keys? Do I want to buy 4 physical keys just because my 2 kids are driving as well? And so on. Biometrics. So there's a wide range of things to do this, and the roles can become more important. And now just to finish the whole complexity thing, those are the classic roles, but more are coming. What about a co-owner? So I own a car, my wife is also a co-owner. What about a renter or a fleet manager? They have different roles, they have different rights on the vehicle. What about a valet? And maybe in the future, the passenger in the back seat, they want to be able to do things. They might want to be able to control the air condition or some parts of the infotainment. So this is getting more differentiated, and this is going to, this is even in the automotive clouds we see today. This is maybe the heart of the whole cloud, to have this user vehicle assignment and roles and so on. And extending on this thing, privacy settings. It's a very basic and requirement that everybody will get is the owner, the driver will want to turn off the data sending. So they will want to mute the car. Easy enough, right? It isn't quite, because in the vehicle context, you also have legal obligations to keep certain things online, even though the driver says no. And also, going back to the slide before, there's just so many roads in the car, and you have to really look into the details of what is possible. I'll illustrate this with some examples. For example, driver activates privacy, but then they have an accident. Of course, the eCall still needs to be able to go out, and eCall is actually, well, it has GPS data, it has speed data, so very sensible data. So that's an example of a service that stays active even though you are in privacy mode. Another example, the owner has a pay-how-you-drive insurance, so they get some discounts based on how they drive, when they drive, and driving style. So what happens if the driver turns on privacy now? Can this data still be sent? I'd probably say no, but what happens to your insurance in that case, right? Yeah, design it well. I mean, last example, you have a company car and your company installs some kind of tracking app in order to track your maybe driving behavior, but also maybe some more innocent stuff. They want to know which vehicles are good or not. Now, your kid is driving. They didn't ever sign any consent about their data being collected, about their driving behavior being collected. So should they be tracked? Can I, as a owner or the person being possession of the car, actually give the consent in the name of my adult kid? So it's quite complex here. And all of these topics that I mentioned, who's the users, who's in the vehicle, but also physical vehicle capabilities. I can't control my roof window if I don't have a roof window in my car. Very easy. Privacy settings. All this comes together if you want to see the vehicle as a product platform. So if you see the vehicle as the center and the platform for an ecosystem. So basically, like your phone, you have your apps. And the automotive cloud is like the central point where you bring all this information together and you kind of calculate, you multiply your licenses times your user in the vehicle, times your vehicle capabilities, and you get out what vehicles are active in the vehicle at that point. So that makes it, yeah, this is the core challenge of the automotive cloud, to enable the vehicle to become a product platform, to become an ecosystem, to enable apps to run on it. Yeah, that's really the point I wanted to make about the complexity of automotive cloud. Daniel will conclude.
So thanks, Torben. There's much more to say, but you see maybe the time is short. So there are 3 more slides to go. I have the pleasure to give it to you. So welcome in the complexity hell. Okay, so this is kind of real life. So obviously, maybe not, but for us, you want to have a one automotive cloud. Okay, there are many strategies to assure that. Right? So we have a many to one relationship. Okay, so about that tough job Jan Jongen was talking in Graz. Right. My point on that slide is that imagine one single vehicle project you're rolling out to the whole world. Okay, so you might have, many have, some don't have multiple brands, but then you have models, you go to markets and so on, and you have vehicle generations where you improve stuff, right? And so you want to tag, to link things to those variants. Don't do it, okay? So it kills you, right? And even if you imagine, or even more, if you see that, it was one vehicle project, but if we look on UNEC or a car, it's having something like 15 years of lifetime, okay? And you're still having one automotive cloud. So imagine the variants, you're having hundreds, even thousands of variants being proceeded on your automotive cloud. And we all have to regression testing, right? Even after 10 years. So it's the ways to solve it. There's no time to talk about this today. Empty slide. Okay. So what you have seen were many business topics, logical building blocks. Obviously behind it, there are technical building blocks, right? So technical services. Many of them, all could be open source, right? And the point here is that you need to keep track of all those things, to have a big picture, okay? Because the feature, you know, the connected feature is an end-to-end feature, right? If you say my service is running, so it's good for you, but maybe not good for the feature. Now let's get a little emotional. Okay, so we were, let's. I don't get the English word for sachlich, right? But so you know, we are software guys, right? We are cloud guys, software guys. So we welcome and appreciate what SDV is about. Okay, so it's CI/CD and early integration. So it's what we do for decades, right? And so we learning from and learned already from the vehicle guys, and we are now vehicle guys. You know, we are automotive vehicle guys. We still love learning with you, from you. And so what's truly needed is a shift north after you split the software from the hardware, right? So we can do the things we want to do, right? So please design the architecture. I heard that there will be some cool talks about that we have maybe refurbished architecture. And so we can do early integration, right? That we have what's most important on that slide, that we have joint development teams, right? That we don't have the SOP on the vehicle side and the automotive cloud is sleeping, right? And after 1 year, we have then workarounds and things like that, right? And no, it's important right from the beginning, deliver potential shippable product increments. Who knows the PSPI abbreviation of you, right? So it's what agile people, it's usual. And finally, you know, the virtualization obviously is needed. Otherwise, we cannot deliver end-to-end running software right from the beginning. So yeah, what you want to have is a seamless running end-to-end system, right? We vehicle with the automotive cloud. Thank you.
And Bill, one slide back, as you mentioned, there's a lot of opportunity for collaborating on the source. Many building blocks. Do you have one or three or two or three examples directly on top of your mind that you could share?
I try. So there are so many, but what you want to have is the kind of vehicle inventory, for instance, right? So it's non-differentiating stuff, right? So you having a domain model of vehicle devices, maybe networks, maybe capabilities, right? And having that piece of service, I would say it's for anyone non-differentiating, right? On the other hand, look in the Eclipse SDV repo, we're having many digital twin implementations, so we are already there, right? And maybe user enrollment could be something, right? So a pattern we see in our project is where the automotive cloud provides high-level APIs, for instance, for shops, you know, where shops can push licenses or products inside, right? So kind of shop enabling or business enabling could be also an open source project. Does it answer?